Infrastructure to Data, exploring interoperability across architectural layers in European cloud initiatives. As you probably know, this event has been organized as part of the CISERO activities of dissemination and communication, so as part of the coordinations and support action together with IPSASIS project. So welcome everyone to this webinar. We have a lot of experts in interoperability today. So before we jump in introducing all of our keynote and session participants, we will start to very briefly introduce the topic that got us together here today. So I'm going to start sharing my screen. Very briefly, as you know, as Europe continues to strengthen its digital sovereignty and build federated, trusted, and cloud infrastructures, this topic of interoperability has emerged as a key enabler for success, not only in Europe, but even beyond. So in this 2-hour-long webinar or session, we aim to bring together key stakeholders from IPSASIS project. This is so to actually get to discuss the role of interoperability in a broader European cloud ecosystem across infrastructure, orchestration, and platforms, as well as data layers. The main objectives of this webinar are to first clarify the concept of interoperability all across these architectural layers, just mentioned, infrastructure, orchestration, platforms, and data layers, highlighting how these layers interacts to ensure the seamless integration and data flow. At the same time, this will serve to showcase these key European initiatives, addressing specific interoperability challenges at each of the layers, with a focus on 5G, edge computing, and cloud infrastructure. The third objective would be to explore the synergies and dependencies across these layers, so as to also foster a coherent and efficient European cloud edge ecosystem, while also highlighting concrete approaches from flagship projects. Finally, this will foster cross-project dialogue to strengthen collaboration and drive forward the development of a sustainable, interoperable, and European cloud environment. Let me very briefly introduce myself. I'm Katia Lavin, Research and Development Project Manager at Innovali Association, a recognized research and development technology center with more than 25 years of experience dedicated to fostering technological innovation in technology-based product and service development areas. I'm a graduate in Bachelor's in International Relations with an MBA and Project Management, Big Data-related technologies and training courses, and count of several years of experience in project management, among other areas. In CISERO project, I'm part of the ecosystem building activities in Work Package 4, while also contributing to communication and dissemination activities, which is what brought us here today. So, just to mention very briefly, first we have our first topic, which is interoperability across infrastructures. Taking this topic into account, we have to be realistic on the reality that it has become a critical challenge as organizations increasingly have relied on diverse, distributed, and hybrid systems. This means that also modern infrastructure has spanned on-premises data centers, multi-cloud environments, edge devices, and legacy platforms, which all of them have different standards, protocols, and management tools. Therefore, it has actually become even a bigger challenge to ensure a seamless communication and integration across these heterogeneous environments, even more complex every day, often leading to this type of issues around data silos, inconsistent security policies, and vendor lock-in challenges. This also is very aligned with the emerging technologies such as IoT, AI, and 5G demand that actually these technologies demand higher level of interoperability to actually unlock their full value. So in today's webinar, we have expert speakers that will showcase their IPSASIS projects based proposed solutions to these challenges. On the second line, we have orchestration platform interoperability that also presents significant challenges as organizations attempt to manage increasingly complex infrastructures. This is very related with the workloads that spread across multiple clouds, edge systems, and legacy environments, where it's orchestration platforms that must ensure seamless coordination with services, applications, and data flows. And where this lack of unified standards and proprietary interfaces, as well as fragmented tool chains, are the ones that often lead to vendor lock-in, integration overhead, and inconsistent performance. So addressing these challenges will require, and currently also require, open APIs, modular architectures, and cross-platform governance that will be some of the solutions that might be mentioned today by our key experts. And finally, we have the last topic, which is data layers. And we have to take into account in this line that data often reside across heterogeneous systems, and each of them have distinct formats, governance models, and access protocols. So this fragmentation creates barriers to interoperability, and also having different metadata standards, security requirements, and compliance frameworks complicate cross-platform data exchange. So having all these challenges all together is what brought us here today. And so that we don't take too long in this brief introduction, let's start with our first session, which is session 1 on interoperability in European cloud ecosystems. If I'm not mistaken, this session is led by Andreas Weiss, Managing Director at ECO Association of the Internet Industry, that is bringing more than 30 years of experience in driving digital transformation across sectors, with a strong focus on cloud computing, artificial intelligence, and data sovereignty. Also serving on the board of Trusted Cloud EV, promoting quality and transparency standards for cloud services in Germany. I don't want to take too long in this introduction, so please, Mr. Rice, the floor is yours. Thank you.
Thanks, Katja, for the kind introduction. Welcome to the audience. Thanks to the CISERO team to invite me for this keynote. Right now I'm in the European Parliament. I hope everything works smooth as expected. And I would like to start to give you, let me say, some food for thought. This works. And also related to the background. As you rightly said, I'm Managing Director of the ECO Association of the Internet Industry. Means we are representing mainly the ecosystem of providers or of actors within the digital infrastructures and services area, which is data center, interconnection services, ISPs, data co-location, as well as cloud provider. So we have around 1,000 members in 70 countries. So it's not just limited to Germany or Europe, it's a worldwide activity. And beside the agenda to shape the internet, we are also operating the internet because we are also operating the DICX exchange. So it's an internet exchange which is acting in 60 locations across over the world to drive the internet. And the internet is something which is quite resilient and quite performing. And if we stop the internet, we might be in trouble. So, and based on this, I would like to share you some ideas about how the internet emerged. And we need to go back in the last century, 1969, where the first RFC has been written. RFC is so-called a request for comment. It's not a standard. It's not a formal priority. This first RFC has been written on a typewriter with 7 pages, and it was the idea to start a joint effort how to build up the internet and how to make it resilient, how to make it performant, how to make it interoperable, and so on and so forth. And the key was here rough consensus, and in the first place, running code, which means let's try it. If someone has a good idea and the community says, yeah, that makes sense, then let's try it. Let's make it happen. And this shows a minimal bureaucracy, fast integration, and at the end, due to the joint effort of all the stakeholders, it was a global interoperability. And when we look at today and we try to emerge digital ecosystems like via the Eclipse Foundation, Simple, Gaia X, and I can name 30 or 40 initiatives who are mainly targeting the same objectives: to make Europe resilient, to support the digital transformation, to make use of data for AI or whatever, to enhance ourselves. And they always start with the ambitious goal, open standards and interoperability. But in the reality, and I can tell you, based on my experience, I've started Gaia X before it has named Gaia X. So this was part of a previous think tank in Germany to start such an initiative. But what we really face the challenge is too many committees. It is too complex. It's getting too slow. And we have a huge risk of fragmentation and low adoption. And this is something we need to take into consideration. I'm not saying that we should start with ROCs. No, of course not. I think we need to be smarter here. And from my point of view, smarter means we should still keep technical specification lean and don't try over engineering. It doesn't make sense to go for 99.9% before we start to double check if this idea is really tangible. And we need to run it in parallel or even run first and then standardize later. Before we try to standardize, well, someone must be clearly said, yeah, this is of relevance and this is tangible and it advances us. Sometimes I'm getting the impression that we're using standardization just to fix an idea or to build an ecosystem around an idea, and then hopefully someone is interested in this idea. I think this is the wrong way from my point of view. And we need a clear open participation. This is painful, of course. You need mechanism to move forward and not to be blocked by lengthy discussions with thousands of stakeholders. But there are sufficient ideas how to manage this and be more pragmatic. And to be honest, when I started with Gaia X, after 1 year and thousands of documents and millions of PowerPoints, I was really annoyed. And I think, come on, guys, we need to show something functional. It should not be perfect. But if we don't turn all the thousands of images into something functional, we will fail anyway. So let me just say this as a kind of key message. Oops. Any specification must be bottom up, and the governance can be done top down. So anyone say, what is our goal? What are our objectives? And this is best case also a business need or a society need or whatever. But then the specification must be done by. Can you hear me? Can you still hear me? Yeah.
Yes.
Okay. But the specification must be done by the teams who are really implementing them, such ideas. So coming to the next page, there's always strategic dimension. So when we talk about digital sovereignty, and this is also one of these major buzzwords where 100 people have 100 different understandings what is digital sovereignty. But at the end of the day, it's at least the ability to control critical infrastructures and data, and it should be a kind of freedom of choice. So, which means we are not saying you're not allowed to use a hyperscaler. If someone says, I want to use a hyperscaler, why not? But in any case, if you have a plan A, you should always have a plan B. You need to prepare it and you need to balance it. You need to be, because I prefer in terms of digital sovereignty to talk about resilience. We want to things keep up and running in a good way. And this also relates to interoperability, of course. I just want to emphasize this. We need to talk about the economic dimension. I'm really in favor of these IPSAs, which hopefully helps us to have a real digital market in Europe. We are not yet there. We still have a lot of cross-border challenges and we are obstacles to create digital value creation. When it comes to data spaces, yeah, it's nice, but it doesn't run in a large-scale operation because we have so much discussions around data, free flow of data and everything. We are still not yet there. And probably need to address this also in parallel. We can do everything interoperable. If legal frameworks do not support it, nothing will happen. And all the work is for the wastebasket. Because we want to foster collaboration, we need to work closer together. And it's great to see in this IPSAs hundreds of companies, relevant companies or stakeholders and entities who are working jointly together on same goals and same objectives. And I like this very much. And we need to consider also the participation of SMEs, because they are the key part to be engaged into such digital ecosystems. Just to remember, 99.2% of our European companies are SMEs, and they represent a lot of GDP in Europe. And we need to take this as a serious goal. Yeah, and like it or not, we need to ensure compliance with EU regulation, GDPR, AI Act, Cybersecurity Act, and everything. But when we come to limits, or probably I'm just following the current discussion about model training, LLMs, and data privacy, which is quite tricky. But we need to solve this, but we still need to follow our own regulation. And, if we think there are reasonable shortcomings, or it will really stop any innovation, then we need to provide sound feedback, what should be done here. So that we are getting to the main goal, building trust services that citizens and companies can adopt and really trust. So this is something which is of relevance. And I'm still totally committed. Interoperability is not a nice to have. It's an enabler for sovereign, competitive, and trusted digital European ecosystems. Coming to my last point, from fragmentation to federation. And also a point I realize when we talk about federations, we're talking about 50 shades of federation. It's quite obvious when you ask someone who's really in the core infrastructure on Kubernetes level, he has a different understanding about federation than a business owner or any technical manager. And we need to find a good alignment and a common understanding of what federation means at the end of the day. For me, it's more important that we replace silos with interoperable and federated cloud services in the first place, but then also connect the tissue between infrastructures, platforms, applications, data, and foremost business. If we don't get the business buy-in on all these ideas, it will fail for sure. We need to carefully listen to business because anyone needs to pay for all these fancy services. Otherwise, it is a dead end. If we try to make a perfect orchestrated cross-cloud edge continuum with smart services, it will fail. It will fail already just due to the lack of SLAs, because a business owner, he wants to have a fluent service offering across over countries. And bringing it to the point, right now we have a good GSM roaming. We need to consider, can we get a cloud roaming as well? And how does it work in the future? So this is more or less the expectation from a business side. Take care about it. And then I'm willing to pay for it. I'm really convinced Aura provides now the framework and the momentum for collaboration. And it's not just about technology. It's about digital sovereignty, whatever this means, and European leadership. So we need to work closely together to overcome all the shortcomings, obstacles, challenges, and move forward. And we need to move fast forward. We are all aware about our political surrounding conditions and what happens here and on our continent. And we need to lower entry barriers for SMEs, also for public sector adoption, because they can also get an upgrade and should get an upgrade and should be smarter and more enhanced by using of digital services. Yeah, we can really say build trust alternatives to hyperscaler login. The hyperscalers are working very good and they're well orchestrated, and we need to do much more to compete here and to build similar service levels and similar user experience at the end of the day. So showcase functionality and improvement potential first before we put everything in standards and try to bring it into operation. And wherever is an existing standard, and we're working closely with W3C standards and similar areas where applicable, we need interoperability to scale up. And there's no single truth. This is a fight, and we need to work jointly and really make the best. And this brings me back to my RFC. Let's be pragmatic. Let's try to solve problems instead to overrule everything and show what is possible, because otherwise you will never get stakeholder buy-in and you will not come into the next phase. This is at least the idea of one of these Aura projects, FANCYS, we are driving on behalf of ECO, and Emma will share more insights here. So far, that's it from my side. Thanks for your attention.
Thank you so much, Mr. Weiss, for your session keynote. It's been very interesting to know how this IPSAS Cloud Edge Continuum related projects are actually contributing to a European sovereignty challenge after all, right? Gaining this empowerment in a European level in the Cloud Edge sector. So to follow up a little bit on with the agenda of the event today, let's jump to session 2 on infrastructure and orchestration layer, if I'm not mistaken. We are focusing on physical and virtual infrastructure integration, edge cloud orchestration, energy efficient modularity. And in this session, we will have speakers representing partners of both Silva and MISG project. So from Silva project, we have 3 speakers. First, we have Andre Antunes Vieira, pre-sales manager at Self-Focus, who is an experienced digital transformation leader specializing in AI, automation, and cloud-native networks. He is currently pre-sales senior manager at Self-Focus, where he drives executive-level initiatives in AI operations and digital strategy, building on leadership roles at Selfnet and Deloitte, among other contributions. National Communication Adoption Group work group leader for the Silva project. He holds a master's degree in electrical and computer engineering from the Instituto Superior Técnico with a focus on telecommunications and systems control. And he comes with over a decade of experience in spanning consulting, telecommunications, and enterprise technology, while also being passionate about turning emerging technologies into real business impact. I think it's first, you're going to interact with your other colleagues, so let me maybe introduce them too, so that we don't have to interrupt. We have also Carlo Cavazzoni, who is Chief Technology Officer at TIM, Telecom Italia from Silva Project as well, with more than 25 years of experience on transport, IP, and SDN control. But also in the last 5 years, coordinating the design and experimental evaluation of cloud infrastructures, supporting cloud-native application and network functions. And finally, we have Luis Velarde Tazón, Head of Infra and Cloud Telefónica, with more than 15 years of experience in the telecommunication industry, and as enterprise and solutions architect in IT and communication networks, in charge of defining the infrastructure, hosting IT and network workloads for Telefónica Group worldwide, and with education with master's degree in telecommunications and bachelor's of business administration and economics. And with this, I leave the floor to you, and apologies for this little issue.
Thank you so much. So I'll be me that will start on the presentation. So bear with me because I'm going now to share here my screen. And I think you can see it. Perfect. So first of all, it's a pleasure to be here and also talking about Silva with my other 2 colleagues of Carlo and Luis. And this is a bit of a continuation of what Andreas was talking about. So why Silva appeared, or why this project was created? This is a project that comes from a common issue, not only for the telecom operators, but also with the vendors. We talk a bit here today about the conversions of the cloud, and here we are going to talk a bit about the conversions of the telco cloud, so the telco workloads. Telco workloads are very special. They have special needs, and during the time, this is an evolution of the telecom network for the past 100 years. So as you might imagine, this created some silos, this created some difficulties, and both vendors and the operators wanted these conversions of this cloud layer. The cloud layer to not only having these workloads functioning on every cloud, but also for what these workloads can give, for what applications they can provide, the interoperability and the costs that can be saved. So the project Silva appears not as a standard, but also to provide these frameworks. So it was created and launched in November 2022 by the main carriers in Europe, but also some vendors. And the project objectives are very clear. So the project wants to release this cloud software framework that is tailored for telco and the edge requirements, and to create this uniformization of the cloud. But also, it's not only to create this framework that is going to be very detailed in the next slide by Carlo and also by Luis, is to create the validation of each workload. So when we talk about here the interoperability, is to put everyone together on the same issue, and here we are talking about the telecom operators, but also for the vendors that are providing these applications and system integrators that will have this role. This is sometimes it's very rare to find it, but this is a project that we find is a win-win-win situation, because everyone that is involving will have a role and it will have benefits with this. So the operators, of course, will have, in terms of the uniformization, a reduction of costs. In terms of vendors that are providing these applications, the applications that make the telecom companies to work, they will able to replicate, and the system integrators also will have their life easiness and will have more opportunities to increase the use case. We find this as a fundamental stone of everything that can be done in the telecom sector. So this is the baseline of the telecom sector. If this is coherent, interoperability checked, we can provide new kind of services. It's not only connectivity, but provide connectivity with insights, and connecting with the data can leverage a new world of possibilities for the operators, and of course companies that want to work with these kind of workloads for their use cases. And now I pass it to Carlo to talk a bit about the real world applications.
Thank you, Andre, and good afternoon to everybody. As said by Andre, the Silva project has been created by a group of telco operators and vendors. Silva is mainly an integration project with the purpose of automate the life cycle of distributed cloud infrastructure using a declarative approach together with GitOps to manage a very large number of nodes. As the creators were telco operators, the focus was mainly on telco application, high demanding telco application that are requiring a lot of resources and features to the infrastructure. But actually, the Silva stack can host any kind of application, and many of the participants in Silva are using the stack for hosting any IT general application. The architecture is scalable, flexible, and can create infrastructure from centralized sites to edge or far edge sites. In this picture, you can see some of the most important use cases covered by Silva, starting from the 5G core hosted on a centralized site, or on the user plane function of the 5G core distributed on edge sites, or also or an application with the different components deployed in different sites. For instance, distributed unit can be deployed in edge or far edge site close to the radio antennas, in very small sites where just a few servers can be installed to host this application that is quite demanding in terms of hardware resources, acceleration, synchronization, and so on. While the decentralized unit of the ORAN can be hosted in more centralized sites to cover a wide area. Okay, if you can move to the next one, Andre. I can give you some more detail on the structure of Silva and on the components that has been integrated in the project to create this framework. And one important thing is that, as said by Andrea before, that one of the main tasks of Silva is to create a working stack, a stack that can be used practically even in a production environment, because we are trying to make it flexible and robust to be used as it is in the, let's say, vanilla implementation, or with the help of integrators that can add to the basic stack other feature to complete it. The key element of the architecture are the management cluster, the one on the left, that is a Kubernetes cluster, but that is not used to host client application. Is a cluster that has the purpose of managing the life cycle of the workload clusters that are the Kubernetes cluster hosting actually the application, and that can be distributed in the network. So a single management cluster can manage the life cycle of a large number of workload cluster distributed. And the core component that has been integrated is Cluster API, that is a CNCF open source project created to manage the life cycle of clusters that is being widely used not only in open source but also in many commercial product. With this and with the Flux that is implementing the automation with Git to automate the creation in a declarative way of the infrastructure. The Kubernetes cluster can be created over different underlying infrastructure, either IaaS like VMware, Sphere, or OpenStack, or we are integrating currently OpenNebula, but also bare metal. And bare metal is the most interesting use case, especially for the edge, because it simplifies the layering in the data center. From the point of view of the Kubernetes distribution, we are also quite open. Currently, it is integrated RK2 or the vanilla kubeadm, but is almost completed the integration of canonical Kubernetes or OKD from Red Hat. So a very wide variety of Kubernetes distribution. The last key element of the architecture are the Silva unit, that is the way in which we are making the infrastructure flexible, because the Silva units are Helm chart defining which component has to be installed in each deployment. In this way, you can define in a declarative way which component you want to add to a management cluster or to a workload cluster. You can define how to build each cluster, and from a single management cluster you can deploy different kind of workload cluster depending on the application that can run on it. With the unit you can also add tools for instance, to measure energy-related data from both the hardware infrastructure, reading all the available information about power consumption, and also to associate the power consumption to each application or container. In this way, all this data can be used to optimize the power consumption of the infrastructure. With this, I would leave to Luis the last part of the presentation.
Hello, this is Luis Velarde. Thank you for giving me the opportunity to talk about the validation within Silva. As Andre and Carlo have been commenting before, Silva is an integration project where it incorporates different open source projects in order to build something that is valid and meets the requirements for different telco use cases, such as 5G, Open RAN, or edge use cases. So the first part is building what Carlo has been commenting, something that incorporates these requirements, something like support of Kubernetes, bare metal or not bare metal, support of CAPI, and some features that are required by these specific telco workloads, accelerators, things like that. But the second part comes with demonstrating that this is indeed valid for the workloads of these use cases, because we want to build something, and actually Silva is building, the working group 1, what it does is building a reference implementation that is valid for different telco cloud, telco use cases. So we need to demonstrate or validate that this is indeed valid for those use cases. And this is where we have the validation program. The validation program is intended to verify that these workloads can make use of these features that have been incorporated into Silva, and verify that these workloads can work on top of these Silva platforms, Silva reference implementation, following the cloud native principles. So in the end, we are validating that the workloads are cloud native because they use the cloud native principles of this reference implementation. And we try to move or promote within the telco industry the cloud native world, which will allow us to have portability between different stacks and eventually have a common cloud continuum within Europe. So how do we do this? We do this via what we call validation platforms. Validation platforms are a set of hardware that we use in different locations to deploy the Silva features. And we do it in what we call different configurations. Carlo has been commented that we have different, let's say, flavors. We can have a Kubernetes distro from SUSE, for instance, or a Kubernetes distro from OKD, Red Hat, that was commented before. Or we can have bare metal and also IaaS from different providers. So in the end, if we meet the same requirements, if we follow the Silva functionality, we can have different configurations and we can validate that the workloads can work in these different configurations. So this is the validation program about first of all, allowing network functions or in general workload vendors demonstrate that they are cloud native because they can run on top of a platform that is basically open source and is an integration of open source projects with no specific attachments to anything underneath. So a standard per se. And as you can see, and as we are showing here in the slide, we have already done this so far with 19 different workloads. We have run these workloads and we have demonstrated that they follow the cloud native principles. They follow the security requirements defined within Silva that are valid for a cloud native environment. They can be deployed into this platform that is a basic open source platform. It's not any specific creation or a specific modification of any open source project. It's just an integration of vanilla open source projects. So we demonstrate that they can be deployed there. we demonstrate that the functionality work there, and we demonstrate that they make use of these features that we have incorporated. For instance, we demonstrate that they make use of the accelerators, things like CPU pinning or SRIOV that are enabled by this platform, or they make use of the in-service upgrade, so the capability to upgrade the underlying infrastructure without any impact in the service, or upgrading the service itself in an infrastructure that may be hosting other workloads. So the validation is intended to demonstrate this, that workloads are cloud native and that the features that have been all integrated in Silva are good for these workloads, for these use cases. And as I commented, we have already done this for 19 different ones and for different vendors. It's not that we have just focused on one. We are trying to work with all the vendors covering the telco environment. And now we are tackling, because basically here it's all 5G related, but now we are tackling the new use cases, the Open RAN and the edge use cases is the next thing that we are doing. So we have a backlog that where we are adding new and new applications to be validated. In the next slide, I introduced something that is important. It was implicit somehow in what I was commenting. Silva is not something that we just came off the blue and we built from the scratch. No, we are incorporating things from other organizations, other open source projects, and actually we are interlaced with many existing projects. So we follow CNCF, or we incorporate CNCF projects such as Kubernetes, Flux that have been commented before. Itself is an open source project, Silva. We interact with security related programs. The security requirements that we follow come from the EUCS, from Europe Cyber Security Group. We also come from, take requirements from other organizations or standardization bodies such as Open RAN and ETSI. For instance, the capability to support the PTP is something that we are incorporating to tackle these Open RAN use cases in order to be capable of deploying BDU and VCU workloads, and also the ETSI NFV, because we follow the ETSI NFV for operation of workloads at the infrastructure itself. And in general, with many different Linux Foundation initiatives. Specifically, lately, we have been talking with integrating or working with Cloud Native Telecom Initiative. That is the initiative where the requirements for a Cloud Native workload have been defined, and we are just following those requirements and trying to demonstrate that the workloads are following them. So in the end, Silva is an open source project that integrates with many other open source projects, and it's not just something from the scratch, but trying to integrate with existing elements. So we have a lot of synergies with many other programs. And I think this is all about the presentation of what Silva is. So thanks to Andrea and Carlos for their part, and if you have any questions.
Well, thank you so much for the Silva team. It's been very interesting to hear with detail what has been done in your project regarding interoperability infrastructures and how you are tackling different challenges in this line. Just so that we can, if I'm not mistaken, we have a panel discussion later on, and also closing remark sessions, and hopefully we will have time for questions then. So I'm going to start sharing my screen to introduce very briefly our next speaker from the MISD project. So let me share my screen. So it should be there now. Yes. So from the MISD project, we have Floris Beuve. I hope I'm pronouncing the last name properly. Who is Alliance Manager, thank you, at Asperitas from the MISD project. He brings a diverse background in engineering, sales, and entrepreneurship to his role as Alliance Manager in Asperitas, holding a bachelor's degree in engineering and a master's in information sciences. Once joined Asperitas as a solution architect, where he played a key role in establishing strategic partnerships. Now he's leading alliances as part of the growth team. And one of the projects that he manages in this role is the MISD project for Modular Integrated Sustainable Data Center, which is the biggest Dutch project as part of the CISERO group, let's say. So I don't want to take too long. The slides will be available later. So without further delay, the floor is yours. Thank you.
Thank you, Katja, for the introduction. I appreciate it. And thanks everyone for joining. Let me share my screen. I think you're viewing the right screen. Should be viewing the right screen now. Let me click presenter mode. All right. So good afternoon, everyone. As mentioned, I'm Floris Boeve, Alliance Manager at Asperitas, a thermal management company and leading provider of immersion cooling solutions for data centers. But I'm not here to talk about Asperitas, but I'm here to talk about Modular Integrated Sustainable Data Center, or MISD project, of which Asperitas is the coordinating partner in a consortium of 7 companies from the Netherlands. MISD, which was already mentioned, is the largest of the 3 Dutch projects under the umbrella of Aura, to which a total of 70 million was allocated in funding. So let's quickly revisit what the EU posed as problem statement for Aura. Can we build a high-performance cloud edge infrastructure that will ensure European competitiveness, where the aim is to realize a cloud edge continuum with interconnected services across Europe? As many of you know, we are faced with some serious challenges to facilitate this. Compute demand will continue to grow, especially with the rise of AI, where nearly half of server sales are expected to be for AI in 2026. And thermal design power, basically how much heat chips generate, can already get close to 1 kilowatt today, and is projected to go far beyond that in just a year's time. This is of course driven by the increasing amount of power that chips consume because of AI, which will quadruple the energy demand for AI data centers by 2030. So power availability is becoming, and actually already is, one of the biggest constraints for data centers. Because of this, European regulations are also becoming more stringent, like the Energy Efficiency Directive, that enforces new data center builds above 0.5 megawatt to report a PUE of below 1.2. So what we need is a different data center model. So what are we planning to do to solve this? Well, in the MISD project, we will deploy a staging lab next to an operational lab to develop and test software and hardware innovations that contribute to performance, energy efficiency, sustainability, and security of data centers. These innovations will later be implemented in 2 interconnected field labs that showcase a decentralized network of data centers of the future. But what does this bring? Well, through a modular decentralized approach to data center design, for example, by placing infrastructure close to renewable energy sources, which will be showcased by those field labs, we will bring data and compute to the user with low latency but high performance and security. By implementing leading cooling innovations in these field labs, we will support the most dense compute in the most sustainable way, while also enabling heat reuse to turn data centers into energy producing facilities. Next to that, we will minimize the dependency on the energy grid by developing orchestration algorithms for load balancing and workload allocation across sites, actually to where renewable energy is available, for instance, while also leveraging site redundancy. We do this with a unique set of partners that each have their own expertise, such as data center design consultancy Deerns, SaaS provider Betterby, who will be joining the panel later on, or Eurofiber, cloud provider and data center operator with one of the largest fiber networks in Europe, our National Alliance of Internet Providers, NB-IP, University of Twente, Research Institute TNO, and Asperitas as the thermal management company. So who's going to deliver what in this project? Well, Eurofiber will deploy and connect the staging lab and later field labs with the help of other partners like Deerns. Well, BetterBe will deploy another operational lab. TNO will work together with the UT to develop those orchestration algorithms to shift workloads for maximum grid of flexibility, while NB-IP will make sure that this happens securely. Asperitas will ensure that the most demanding workloads can be run with the lowest power overheads for cooling, while ensuring that all of the generated heat is ready to be reused. And next to that, the UT researchers will provide thermal storage options to store energy and cover for spikes in energy demand, next to also initiating ecosystem collaborations. So some major accomplishments have already been achieved. The staging lab is now up and running with new hardware innovations. For instance, passive immersion cooling system has been deployed, which has the lowest energy overhead on the immersion market. This has contributed to the first PUE reading of 1.03, which will only be improved. But other cooling innovations have also been deployed, such as rack-based immersion and direct-to-chip cooling solution in the staging lab, or even adiabatic cooling in the operational lab of BetterBe. We will soon also deploy an active immersion cooling solution that can cool over 2 kilowatts per processor, while University of Twente is researching thermal storage options to capture the heat that is produced by this. But also new software innovations are to be implemented, where a concept orchestration algorithm was developed and will be tested to shift workloads across sites. Some orchestration tooling is already in use in the operational lab of BetterBe, and more orchestration tooling will be developed, which is planned to be made open source. This staging lab at Eurofiber is actually already connected to another environment run by Lindner in Germany. This is to test basically the first version of a decentralized network of data centers. And we're open to other innovations and, of course, collaborations in that sense. So that's why we would like to welcome specific use cases or business cases you may have for our staging and field labs, as well as welcoming real users and their workloads. And of course, we welcome more collaborations, for instance, in monitoring and control or intelligence and optimization. And when it comes to our view on key tools and standards for practical interoperability, which is, of course, one of the topics of today, or one of the main topics, we believe that we should stick to existing industry standards like standard protocols or using Kubernetes and stay away from anything proprietary to also enable that the infrastructure layer, which we are mainly focusing on, will facilitate interoperability. And we should also ensure that most of what we do, or basically all of what we do, will be based on open source. So that is it for me. Thank you for your time.
Thank you so much, Floris. It definitely has been very interesting to know how you are doing it in the MISD projects. If I'm not mistaken, you will not be able to be in the panel discussion, but we will have your colleague Martin, I think that's how it's pronounced. We will introduce him later. So let me jump to our next session. Thank you so much again. So our next session is on the platform and services layer. So this is very much focused on the federation of services, identity access management, and the unified orchestration and compatibility across sovereign and public cloud environments. So in this session, we have speakers from the ARCIS and FACES project. First, we have Mr. Javier Arnaez de Pedro, head of the ARCIS lab from ARCIS project. He manages the ARCIS Innovation Lab, coordinating different research and development projects of the company, which is aimed at facilitating the development of innovative technological solutions in the IT services market and boosting the digital transformation of companies. If I'm not, here, as you can see in the slide, he's a computer engineer, expert in different application development technologies, and he has held several positions and responsibilities in the technical areas of the company, collaborating mainly in product lines of servers and cloud infrastructure solutions for enterprises. So, Javier, I leave the ground for you.
Okay. Thank you very much, Katia, for the introduction, and thanks to all of you, okay, for listening. Let me just share my screen. Okay. Okay, so do you see the screen? Okay, so let's start. What I'm going to talk about today. I would like to show you, to demonstrate in a more practical way what interoperability means to us, for our users, our customers, and how we have been applying in our services since time ago. Because we always believed that users should have freedom to live if they wish, and they have to trust to a provider. Okay, so we don't have anyone has to force them to stay. And now with projects like Aura within the IPCIS, we can do this in a much larger scale. Okay, so I will guide you in this short session through some services that we offer and the interoperability features that we allow to our customers. And finally, I will tell you about what we are doing in Aura regarding this topic. So what you see here is like the look and feel that our customers see of our main product regarding cloud and infrastructure services, where we offer to our users to be able to manage different infrastructure in a virtual way. Okay, so servers, either dedicated or bare metal or cloud, different network parts like firewall rules or load balancing, storage, of course, share and block storage, and also some security features. Okay, so this is like the main point for our customers to manage the platform. And when we build these products, we have always in mind how the customers, how the users can come with their services, but also how can they go. Okay, so when we define these services, we try to make them as easy and interoperability as possible regarding different things. For example, we try always to offer a really fair price. Okay, usually it's pay per use. If you use a server 1 day, you will pay 1 day, 3 hours, 3 hours. Okay, so no hidden commitments, a clear price that any user can see and understand. Okay, so no hidden minute pricing and so on. So things that they can understand. Another important thing that we have seen for users that come to our platform and also users to live, they want to have freedom and to have tools so they can bring usually servers to us and also export them to move them into another provider, or sometimes because they want just hybrid solutions. Okay, so having services in different providers. For that also is really important to have APIs. Okay, so all of our interfaces can be managed through APIs, so the users can make different automations and also to make automatic replications. So if they want to move or to have synchronized firewall policies and so on, it's really easy for them and it's automatic. What I guide you so you can see an example how a real customer face these issues. I will let you know how that can be done. Okay, so if a customer, for example, wants to bring a new server into this platform, what they have to do is just create an image from importing. Okay, we allow the main open source format, also some proprietary, okay, but always available open source, and the customer just have to import the image, and once the image is imported, they only have just to create a new server from that image, and that's it. Of course, maybe depending on drivers, they have to fight a little bit with configuration, but it's an easy to that. And in the same way, if they want to export, okay? For export a server, what we recommend, have a manual for the users, is doing the same with some software that is available, like Clone Silla, and with the same feature that I just told about, a customer can just import an ISO, in this case a Clone Silla, mount that in any server they have, start, and then they can create an image from the server and then export or move the server to any place. Okay, so it's really easy for them to do them. It's open. Another important thing that we have seen, especially for big customers, now that it seems, I mean, since I think 15 years, IPv4 is almost dying, but it's still there. But some customers, they also bring their subnets with them. So we have internally prepared a tool to make this process fast and easy for the customer. So they only have to indicate which is the subnet and the different technical values that is needed, and we can make, usually in just one day, available that subnets into our platforms, and the other way around. Okay, if they want to move, then that they are free to do it. Okay, so this is also really important for the users to be able to move not only the services, the storage, but also IPs. And now I want to talk about the Aura project within the ICE and how ARSYS is participating as a direct partner. Our main strength is our infrastructure, okay, what I've been talking until now, and our main goal is to expose and federate this so it can be used freely, not only by end users, but also for collaborators of the project. And for this reason, we are like having partnerships with collaborators within the IPCA that they are creating like meta orchestrator. So software or APIs or any kind of standard to make things available in an easy way, okay, for the customers. For that reason, we are part of a sub-project of Aura that is called Virtora. It's led by the company Open Nebula, and it is defined, it's like the ICE software stack for virtualization. So the goal of this software is to allow to the users, to the end customers, to manage services from multiple providers from one single interface, and with the freedom to move easily those services among the providers. Okay, so always using European open source technologies, and with the aim in mind of building a sovereign multi-provider and its cloud for the European Union. So here you have a diagram of how Aura it's built with four different work streams. The first one with the infrastructure. The next one, that is the main one for us, for Virtora, is all the middleware to make possible that infrastructure is available for customers. And then about that, we have the data processing, and finally the use cases. Okay, so this is the whole picture. So what is our mission with Virtora that we also try to do with any other similar initiative within the project? It's really difficult. I mean, every provider does the things in a different way. Okay, so making this kind of meta orchestrators is really difficult and challenging, and we have to find some common ground in order to make it possible. So in this case, what Open Nebula is trying to do is to have APIs, so different providers can join or can offer dedicated servers or bare metal servers connected to them. So once they are connected from their software, the end customer is able to create host dedicated servers, but especially virtual machines, virtual servers within those hosts. Okay, so our mission basically is to enable our infrastructure through open source languages as Terraform, and using our public APIs. Okay, Terraform is an open source tool that allows you to define and manage the IT infrastructure as code. So making it easy to automate, version, deploy resources across multiple cloud providers. So it's a kind of a common language for doing infrastructure things. We also manage public subnets and networks in order to make this work. And then the end customer from OpenNebula is able to create hosts or virtual machines. Okay, so to finish, I will show you how this looks like in a visual way. Okay, first, one of the important things for these meta orchestrators is that the different companies, as us at Arsys, join to this initiative, because you cannot create a standard if nobody is using it. Okay, so it's really important that companies like OpenNebula define these things, and then other companies as us, or all of these that you can see here, join to the initiative, because then is when it is useful. So this, what you can see here, is like the panel of OpenNebula, and here is where a customer can create a host, that means a dedicated server or bare metal server, and then within this host, the users can create in a similar way virtual servers. And the good thing here is that these virtual servers are created in the same way in all of the hosts or bare metal servers. That means that as they are created exactly the same, it's really easy to move them between different data centers, different providers. So that is what it makes, I will say, like the magic. Okay, if the server is created the same way, then you can freely move from one provider to other. So this is our main work in Aura project, how we contribute with the interoperability in the European Union. So thank you.
Hello, Javier. I was about to tell you that we were a little short on time, so thank you so much. Just in time.
Yeah.
Thank you so much for your presentation of what you are doing in your IPSIS Aura project together with other IPSIS projects and members that some of us have heard about. Let me very quickly introduce our next speaker, who is actually the only female speaker today. I do want to mention, which is quite outstanding. We do have to highlight the importance of having more female representation in cloud edge sector industry. So we have Emma Vervine, Senior Manager of Innovation and Digital Ecosystems at ECO, Association of the Internet Industry, from FASES project, who is passionate about bridging the gap between technology and collaboration, supports the development of resilient federated ecosystems that empower business, governments, and individuals to unlock the full potential data, and currently leading the FACES project under the Aura initiative, focused on advancing cooperative data ecosystems to enhance flexibility and independence in cloud and edge environments. And let's try to get the time back on the agenda, please. Thank you.
Thank you very much. Let me try to first share my screen with you. All right, then. Thank you very much for this kind introduction. Good afternoon, everyone. So, I mean, it was mentioned already in Andreas' keynote as well. So I think the biggest challenge that we are facing, not looking at just one specific sector, it doesn't matter if it's companies from manufacturing, mobility, aerospace, the challenge is fragmentation, right? So everyone uses different cloud services, different standards, different orchestration tools. And when you try to collaborate across industries or even just in one industry, you really quickly run into walls. And while most projects within Aura, I also got the impression today for the first with the first presentations, are more infrastructure related. We try to tackle the challenge of fragmentation from a different level, I would say. The idea of FACES, as well as Aura, of course, is really simple but powerful, right? Instead of forcing everyone into one centralized platform, we want to enable federation. So our focus within the project is more on the adoption and the setup of ecosystems where partners can collaborate while still maintaining autonomy. I think that's really important. Even, of course, the discussion of digital sovereignty is always also important when setting up ecosystems. To make this vision work within FACES, we are aiming to deliver open source, reusable components that can be adopted by industries of all kinds to set up and operate digital ecosystems, or how we call them within the project, federations. So you can think of the components as building blocks that you can pick up and use to create your own sovereign yet interoperable ecosystems. We are focusing on three main deliverables. First of all, we are working on a multi-provider SLA governance framework, right? So this will give us a shared taxonomy for multi-provider SLAs, makes them also machine readable. And we also aim to provide a playbook so that service quality can be governed transparently and enforced consistently, even in complex federations and ecosystems. We have conducted several workshops already and are right now in the final phase to write down all our results into one paper and publish it by end of September. And second, we are also working on a digital contracting service on open source basis. This tool will support bilateral, but also multilateral contract negotiations and management. I think that's really important when we talk about setting up complex ecosystems. It will also combine e-signing with qualified electronic signatures, for example, the new EUDI wallet, to ensure that contracts and federated ecosystems are legally binding also across borders. And third, we are introducing a new innovative approach. We call them the federation architecture patterns. These are modular blueprints, or you can even say orchestrated templates that show you how to build and operate trusted federated digital ecosystems in practice. So they are designed to be reusable, so different industries can adopt them to their needs. We are in the final phase to publish our first federation architecture pattern, where we are orchestrating open source microservices and code. So in the end, you have the functionality to onboard new partners into an ecosystem, because we identified this as a really reoccurring process in ecosystems. When you plan to set up an ecosystem, you at one point have to onboard partners into your ecosystem. And this is, of course, something where identity and access management is really important, and where we help with modular blueprints that can be really quickly deployable in the end. So in short, FATSIS is tackling fragmentation not with centralization, but with federation, providing governance, but also tools and technical blueprints that allow us to move forward in a truly interoperable cloud landscape. Maybe to dive a little more or to bring more alive into with a concrete example, we are also collaborating within Aura with several partners for proof of concept projects. Our first partner for collaboration was Airbus, or maybe you know the project Access. The idea here was really to demonstrate and test how decentralized principles and also open source technologies from the XFSE stack can actually work in real high regulated industries like aviation. So our focus was on the aircraft itself. We were treating it as a flying edge device that should seamlessly integrate into a federated cloud infrastructure, right? So imagine a plane not just as a vehicle, but as part of a digital ecosystem that securely exchanges data and services with airlines, airports, service providers. To make this possible, we worked on scalable trust chains, federated catalogs for services and assets. We also have digital wallets, also web-based wallets that allow both humans and machines to prove identity and access rights. And with these elements in place, we could enable collaboration in several use cases. First off, aircraft maintenance, where different parties need verified access to sensitive data, but also, for example, fueling processes where multiple stakeholders must coordinate in real time. What was really important here, and I would really like to mention that, is that it was not just an IT integration exercise for us. It was really about showcasing the transformative potential of federation. So how identity-based trusted business processes can actually change the way aviation operates. For this, we heavily relied on open source components from the XFSE tool stack, so a decentralized identity framework based on self-sovereign identity, federated catalog as a distributed registry, and also an orchestration engine to tie it all together. And our experience here was really that it's also not only an interoperability challenge, but also a mindset challenge, right? So many organizations, especially bigger ones, are still used to centralized siloed platforms. And the idea of just federated ecosystems is not yet mainstream, and it requires also a cultural shift towards trust networks and shared governance. And this is really where we could prove with Airbus that it's manageable and it's it can be done, and we are really happy to also identify further candidates for proof of concepts for collaboration in the future. So we have budget still to support also other proof of concepts. Our key tools and standards for practical interoperability, as mentioned, are the Federation architecture patterns, where we are already orchestrating open source components as reusable templates. We also have an orchestration engine. It's an open source low-code engine built on Node-RED. That was further developed with features from the XFSC tool stack, and its purpose is really to make orchestration accessible, right? So instead of writing thousands of lines of code, organizations can quickly set up and automate federated workflows, and this is also how we are building our federation architecture patterns. Mentioned already many times, everything is supported with the XFSC tool stack, which provides the baseline open source components for setting up federated ecosystems. Tools are openly available through the Eclipse Foundation, and they ensure that what we build is not proprietary, but community-driven and extensible. Of course, technology alone is not enough. Interoperability depends heavily on standards. You guys know that FATSIS integrates a wide range of them. We are focusing on W3C, verifiable credentials and presentations for identity, OpenID for VC for standardized credential exchange. We align with the GaiaX Trust Framework for anchor compliance and catalog integration, but we also include frameworks like self-sovereign identity, JSON LD, OpenAPI, you name it. But really, the idea is by combining open source tools with international and European standards, and also initiatives to align also with initiatives in Europe, FATSIS really tries to ensure that federated ecosystems are not only technically feasible, but also scalable across borders and also across initiatives in the best case. Maybe one last slide to show you as well. At least I see FATSIS not just as a research project. I see FATSIS as an open invitation to all of you to collaborate. So these are, I put some points on the slide where you can get involved and benefit from what we are doing within FATSIS. So first of all, we shortly will have some tendering opportunities. So whenever we launch calls for turning technical specifications, such as the contracting service, into operational code, these are published transparently on our website. So this allows experts and companies to actively contribute and also shape with us the FATSIS deliverables. Secondly, you are very welcomed to propose new federation architecture patterns. So if you identify or recognize recurring processes in your industry when setting up ecosystems that would benefit, you can submit the ideas to us, and we may develop a next federation architecture pattern out of that. So we can, I'm really open to discuss this further with anyone who has ideas. We also organize hands-on workshops. I put 2 links in here because they are already happening in September. The first one will cover the fundamentals of the orchestration engine. So really a hands-on workshop to explain to you what it is, how it is used, how it can be deployed, and what you can do with that. And the second one is really to explain the whole concept of federation architecture patterns and really walk you through the first federation architecture pattern that we already developed and is already published in the Eclipse Foundation repository. We also plan several events, already 2 for you to save the date. In November this year, we will host an event in Berlin dedicated to multi-provider SLA governance. We really want to discuss our results and our playbook and our taxonomy with the community, but also discuss it with political key stakeholders in Berlin. So this will be a 1-day conference, and in June next year, we will hold a 2-day conference, the FATSIS Connect, where we aim to bring the Aura community together, but also industry and policymakers and industry players to really discuss the whole setup of ecosystems, interoperability, and demonstrate what we have achieved so far. And a warm welcome is, of course, for everyone who wants to join the open source community, the XFSC project that we are also leading under the Eclipse Foundation. We prepared a developer hub. I put the link here as well for you to maybe browse through. It's an onboarding guidance for everyone who wants to get involved and also contribute code in the future. And finally, as already mentioned, if you have any if you identify processes that are really siloed in the moment or centralized that you want to transform and showcase the federated approach with your own business processes, we are happy to provide also guidance, consultants, and also the technical means for a proof of concept. So there are many entry points for collaboration, and I'm really happy to dive deeper with you into the topic later, and thank you for your attention.
Thank you so much, Emma, for your presentation. It's very interesting to see how there is one word that is coming quite often, which is, after all, synergies, right? Because after all, interoperability has a lot to do with collaborating and working together. So a little bit on that line, let's jump into the last session on data layer, and so interested in interoperable data sharing. So I'm going to share my screen again to introduce our next and last speaker, who is Mr. Gabriele Lospoto, technical lead at Reply, from the Cloud Computing at Edge for Data Network Service of over FTTX ORAN and ASP4AGV project. So that was long. Sorry if I didn't pronounce it properly. He got a PhD in computer networks from the Roma Tre University and started his career as academia researcher. After that, he moved in a telco operator with the role of network architect, and finally joined Replay during May 2020, serving as technical lead. You can access more of this little bio later after the webinar, but anyhow, the floor is yours. Thank you so much.
Thank you to Katia for your presentation. Let me start sharing my screen. Okay, so it's a pleasure to me being here as a speaker. Good afternoon to all the attendees. In this session, I will present and talk about what Reply is bringing without our initiative. Reply is contributing to two work streams, work stream 2 and work stream 3. For us, interoperability at data layer must be supported by a platform, essentially. That's our main topic, and this is where we are working and we are contributing. We are working on a solution which is an hyper-convergent multi-domain orchestrator. Actually, is a framework, completely software-based solution, which in our idea should be able to combine computing and network resources in order to give a single point of entry to all the consumer of the cloud edge. Our orchestrator, as I said, supports different kind of network technologies, ranging from fixed to mobile networks, without depending of any specific hardware component. Essentially, the baseline of our solution is what is decoupling software from hardware, essentially. And this is done mainly by providing several layers of abstraction and orchestration towards the resources. One of the main tasks is to support what is commonly known as a cloud edge continuum, namely the ability of deploying applications seamless, namely not depending on the underlying infrastructure. This is very important because one of the main aspects, at least in our opinion, with respect of interoperability, is abstracting from the infrastructure. That's very important because it impacts the application itself, which is not depending to any specific environment in which that application will be deployed. That's one of the target of our contribution within IPSISES. Our orchestrator is also designed to enable pervasive connectivity, which is based, as I was saying, on heterogeneous networks. This should allow interoperability and also portability in what is common recognized as a multi-cloud environment, so that many applications coming from different markets might be supported. In terms of real-world applications, we intend to support as many markets as possible, ranging from manufacturing, education, sport and entertainment, hospitality, all markets which typically come from very different requirements, might be technical requirements, or not qualitative requirements, just to be as a single layer of abstraction towards the infrastructure, allowing different services which potentially use different applications to exchange data smoothly. And for us, an important aspect supporting and enabling this aspect, this topic, is a platform which is able to create a common layer of access to the underlying resources. Of course, there are a lot of challenges in doing this. Because typically at infrastructure level, there are a plethora of different technologies, and aggregating them sometimes, quite often actually, is not so trivial. But in our opinion, this is one of the key factors to support interoperability. I mean, making the application or the software layer, if we want to call it in that way, completely decoupled from the infrastructure. Of course, allowing data to be exchanged over cloud edge ecosystems implies secure communication channel between domain, because not the whole infrastructure might be owned by the same organization. So different organizations might interoperate to allow the data exchange. So securing these communication channels is essential, is crucial, is very important. Even integrating multiple network components and technologies is not trivial, but is essential. There are some applications that might need to use different type of connections, or might need to rely on some, for example, roaming approach, which is already available in some mobile networks. So combining it with the ability of moving applications in the cloud continuum is essential, but for supporting this task is crucial to integrate multiple network components. Another key challenge is about resource usage, because it's not always trivial to use resources in an efficient way, especially when artificial intelligence is coming into the game, because as all of us know very well, artificial intelligence component might be very resource consuming very often. Last point, but probably one of the most relevant and challenging one, is to use standard interfaces and data models, as some of the speakers before me already mentioned, as one of the most relevant and critical aspect. Final remark on key tools as standard, I would like to emphasize two main aspects. The first one is domain interconnections, which must rely on standard interfaces and data model, because otherwise interoperability and data exchange might be very difficult to reach if there is not a common layer which support the data exchange. And for the data exchange itself, it's very important to use tools which distribute the data across edge sites. There are a lot of applications nowadays. For example, many applications based on artificial intelligence which needs to compute data locally without centralize them. So having tools which can distribute data across such site, improve availability of data, securing those data, and also make those data available according to some geolocation rules is essentially. I would close my presentation here to give some time for the panel discussion, and thank you for your attention.
Thank you so much, Mr. Gabriele Despoto, for your presentation. It's been very interesting to see a little bit how this data layers interact with interoperability challenges, right? So, as mentioned, now we jump to the panel discussion. If I'm not mistaken, our colleague George Kousioris, Associate Professor at the Department of Informatics and Telematics of Harokyopo University of Athens, will be the moderator. You can find his short bio here, and we have different representatives from the CISERO project already introduced, André Antunes Vieira and Luis Velarde Tazón. Then we have Martin Werman in representation of MISD project, interim manager and consultant at BetterB, in representation also from Floris, who couldn't stay as mentioned. And then we have Javier Arnaez de Pedro, Emma Vervain, and Gabriele Despoto again in this discussion. So thank you so much. And George, you can take the lead.
Thank you, Katia, and thank you all for your very interesting discussions during these presentations during this session. So if I can share my screen, I have prepared them from your presentation some key topics that we can, let's say, base the panel discussion on. Okay, I don't know if you can see my screen. Can you see my screen?
Yes, we can.
Yes, we can.
Okay. You know, one of the purposes of the workshop is also to see the cross-layer dependencies. So, based on your presented material, I try to somehow summarize some of these interdependencies. So one potential aspect that I saw is about sustainability from an energy consumption point of view. I think many of you mentioned about energy consumption, either at the physical layer and optimizations from the management layers. One point of discussion is how easy it is to forward this information, how much integration is needed for energy-related information to go from the server to the management software, and also how easy it is to integrate that into software energy efficiency. So how can we write better software eventually that will take under consideration energy efficiency and better sustainability? So one point could be in that direction. I don't know who wants to start with the discussion or give their viewpoint on that direction.
I can certainly comment on that. So yeah, I do have a little bit of a generic, all over global answer for this. So right now, there's not a lot of features out there to actually get that information into your software. But given the fact that within the MISD, of course, we have that challenge, because we are looking into optimizing the software and optimizing the hardware and working in a better way with thermal management and energy and peak shaving and all these kinds of fancy technologies. So we would see this as there's two approaches, we would say. One is that we would have something like a central system where we store statistics and metrics of all the things that are available, and allow with a generic API to all those layers that are in play to talk to that and make decisions based on that. Because some of the layers just report back what they have, and others of the layers would just query it and see where do we run workloads and things like that. And the other possibility is that we use, well, just a little bit more for the technical people around us, but some of the technical people might be familiar with tools like Cloud Init, and we might be able to extend the Cloud Init tooling to basically expose certain metrics and variables from one layer to another. Within the MISD project, we have already defined a data model for this, and we've shared this, in the University of Twente and the TNO research organization in the Netherlands is also working on this, and which basically covers like electricity costs, where would it be cheaper, what is available in a data center with regards to resources. And yeah, we're looking into making a data model for this. We already come up with something, and we're looking at possibly making a standard for this. I think that's that would certainly be beneficial in the greater scheme of things. I'd love to hear what other people's thoughts are on this.
But on my side, so also for these two heads that I have on Silva and Self-Focus, but it's exactly that. This is not a trivial exercise, because it's not just to see the metrics of consumption of the hardware and doing this fine tuning. In this part of what I see in terms of Silva helping these is in terms of the validation and interoperability. So understanding the workload is not just to find and to see the consumption, because in the telco space is a bit more challenging. You cannot just turn off because it's not consuming. You have trends, it's a seasonality. And I think there is still a need in the market, not only for the telco workloads, but also for the others, to understand how the workload is going to function. Otherwise, doing the energy consumption is going to be an exercise that doesn't give us the full benefits if we just look at what is being used as the CPU, as the RAM, as the storage, as how I can dimension my data centers. It feels always a bit short. So we need to have this holistic view of everything, beginning of which service that is providing, going on the applications, and of course finishing on the infrastructure that these applications are running. I think you need to have this holistic view, and it's not easy to have this holistic view, of course.
Also, something to say about Silva is that it tries to do it defining a reference or using open source, so that we do it kind of in a standard way. We have identified that, for instance, Kepler open source project allows in monitoring the software, so the energy consumption. So we are promoting to use Kepler. This is what we have under the Silva reference. And the same for other interactions with upper layers. This is why we are promoting CAPI as the way to manage and operate the deployment of the infrastructure. So Silva at least tries to do it in a standard way.
Just to add a very quick consideration on top of what other colleagues already said, energy consumption consideration shouldn't be a static view over the environments, but should be as much dynamic as possible, because energy consumption may change over the time due to several reasons. So somehow the platform managing and orchestrating all the workloads should be able to react almost real time to any variation within the environment, allowing the energy consumption to be as much fair as possible, let's say. But just to say that having a static view might be very, very, very limited, because while the application is running, many other dimensions might change over the time.
Okay, thank you very much all. One of the next points was something that was mentioned again by many of you. So both in the keynote aspects, but also by FASIS and I think ARSIS as well. So about the orchestration layers, or in case higher level layers, using APIs from lower ones, fragmentation issues were discovered and were mentioned. So it is my understanding that all of you have a common view that okay, standards in many cases move a bit slow, so we should probably focus more on federation frameworks that have a kind of adapter logic, things that we can build quickly, proof of concepts, and some intermediate layer for interoperability, and then come and integrate different, let's say, resources or providers based on this adaptation to the federation, let's say, interoperability. Is that right? Any specific views on this?
Yeah, I can I can start with that. From our point of view at ARSIS, we see this like a common issue in any kind of federation. At the end, we, among other companies, provide infrastructure, and we have our own APIs, way to install servers, define network, and so on. So it is really difficult to connect that easily with different providers. So what I think, and this is totally a personal view, is that in these big projects like Aura, we have to define roles, and probably from the very beginning try to define one or several companies that define some kind of standards or federation way of work, and then the other companies have to make some compromise and say, hey, we are going to follow that. Because if not, sometimes what I see is like a lot of work trying to define something, but nobody's doing that. So you can define a standard or a federation, but if there are no companies accessing to it, then it works nothing. And also I believe that it's better to start from something simple. Okay, so for example, and I came to the Aura project a bit late, so it was early this year, but when I see the different projects or initiatives, and I check Virtora with OpenNebula, I see that they wanted to start with something simple, like a dedicated server, a bare metal server. So that can be simple. And then all the virtual servers, let's create in the same way with open source mechanisms. So then you have something in common. So I think that we have like to differentiate roles, okay, to defining some standards or federation that will follow a standard, and then just to really use that standard and making something that can be really used, but by a collaboration or by an end customer.
Maybe to add from the FATSIS project, I mean, as you already understood, we understand federation differently than most of you that are more working on the infrastructure. layer, as we are more on the coordination layer with setting up ecosystems. But I think what is important when we talk about standardization or like technical standards, I think it's also important to take the time, and that's also what we have done, to really first analyze what past initiatives already worked on, right? So, I mean, especially Gaia X, we can argue if it was a success or not, but at least from my point of view, within Gaia X, there were already many European players discussing over 4 years standards for setting up federations or ecosystems. And I think there is a lot of food for thought that we also took into consideration. And also that's why we decided to align also on standards that were decided to use within the Gaia X initiative, because there a lot of players and companies I also see in Aura again, or in different initiatives. So we try to find synergies with also other initiatives and projects. And I think that's also really important, because otherwise we will have, again, a siloed view on what we will use here, then other initiatives will use something else. But I think also when we talk about adoption, I think it's really important that all of us within Aura are working more on community engagement. I think it's really critical, because in the end, if only a few players will contribute to code and like this discussions, especially on in the open source world, I think that's not the right way forward, right? So I think if we want to have adoption, we need to have a bigger community to decide on things and discuss things.
Also, I wanted to add one of the parts that I completely agree on this, but also there is two kind of projects that are the projects that wants to put people to talk about the issue and doing the standardization, and the projects that they want to be considered as a framework. And when you are a framework, not only are you solving can be started with a small issue, but it needs to also to have the adoption, of course, and after the adoption, the rollout and the lifecycle management, and even the roadmap of what is happening. For instance, in Silva, we are very concerned, and this is on our top priority. What is going to be the roadmap? How the people can see the evolution of this framework, and to don't be just one thing that they are going to use one time. And of course, this brings more people together to a vision, to the uniformization that we have. So it's also very, very important, not only the adoption, but then what is going to be the roadmap, how is the adoption, who's going to operate, because for the end user, it's always pops on their mind in terms of lifecycle management of these frameworks.
One little comment just before we continue. Remember that there should also be an open floor for attendees to actually pop up some questions. So maybe we can give some time for them, given that the closing remarks are expected to start at 4:25. I do not want to interrupt though, but just to remind.
One quick comment on all this. In the case of Silva as well, we identified a set of requirements, but we didn't want to just say standardize and say these are the requirements, but build something. So this is the benefit of open source, that you build something that demonstrates, and actually you can confirm if those requirements are valid or not. In the same way, I think for the case of IPC, that it has been commented now, the pilots in Virtuora and also in Labora are important to demonstrate the federation frameworks that we have been discussing for some time. So to me, the benefit of open source, or in general of implementing things, is that you can see for real the effect of something and not just describe standards that someone may implement later.
Thank you. So I think let's sum up a bit the last two slides. So one of the issues I have documented was exactly what you mentioned. So whether we need some community engagement or concentration to avoid this fragmentation. So I jumped that and just mentioned to have in mind for future collaborations or for the QA afterwards. So it's my understanding that some form of collaboration could be based on, let's say, agreeing on collaborating on a specific area of focus of the tools. Obviously, this will not happen primarily for the lower layers where everything is based on Kubernetes and very mature projects. But is there some common ground on the IPSA initiative and potentially beyond to focus on some higher layers of open source tooling, whether it is about identity management or energy governance, the patterns mentioned? Did you see that feasible, and how can we as a CISERO project help in the above aspects? So organize a bit the community, trigger engagement, and things like that.
So I see there are some questions in the chat. Xing Dong, you can, if you want, you can put your microphone on and post it yourself.
Okay, so
Yes, could you hear me? Thank you very much for giving me
Yes.
this chance. Okay, I would like to explain my questions. I have two questions. First of all, thank you very much for the great presentations. Yeah, the two questions. At first, is the how evaluate our development for the federation services. Do other hyperscalers outside EU also provide similar federation services? This is the first question. And the second question, would you collaborate with any manufacturing X projects for the data space development? For example, the energy data X for the interoperability testing. Yeah, thank you.
Maybe I can start with the second question. So at least from the FATSIS project, yes, we approached several other initiatives and projects like Manufacturing X, but especially we are aiming to collaborate with the Mechanical Engineering Industry Association, VDMA in German. I'm not sure if you're familiar with them, but they're also, of course, really involved heavily in the manufacturing, and we are thinking about like also having federation architecture patterns for this industry. So we are trying to collaborate with them on like requirements for sure. And also we are in alignment with Simple. It's also an European an initiative from the EU Commission where we want to showcase that different ecosystems like Aura and Simple can be interoperable. So we are trying to set up a testbed at Telecom and on the Open Sovereign Cloud to discuss this. But these are more on a discussion level right now, but I think they will be more approached next year.
Okay, thank you very much. Yeah. And for my first question.
Yeah, I can answer that. So you're looking at hyperscalers, something like AWS or GCP or other hyperscalers?
Yes, general.
Well, so I know that Azure has a specific cloud connector that allows you to connect with AWS, and the AWS has it the other way around. But yeah, I think there is support, but it's not as in the way that I think with that how we want to do that within the EU, within the MISD IPSI process. And other than that, I think there are several open source tooling that allows you to run real hybrids. So I mean the Iron Core project, for example, allows you to manage your VMs in both on bare metal and on several cloud providers. So there's certainly open source tooling around for that.
Okay, yeah. And about the cross-border, cross-border projects, do you have any experience or use cases for the cross-border projects? I mean, it's cross European, US, European, China, or European, Japan?
Well, the whole idea of the IPSI-SIS program is to become sovereign and step away from US and other outside of the EU-based providers. So that would be fall outside of the scope of the project.
For the silver part, replying to both of the questions. So the hyperscalers or the other companies are not doing what Silva is doing, because as we explained, and it was explained by Luis and Carl and me, this is a framework for the interoperability and the fragmentation of the telco cloud specifically. So, but also we have companies that are outside of EU that want to be also validated and to be on these platforms. So, for the first question, no, but we have companies that want to be validated in our framework. And for the second, we are already in the initial collaboration outside of the telco space. So this is sometimes is a bit viewed only for the operators that are going to have the huge benefits, but this is a project that can have workloads for you to have a private 5G network. So we are seeing some interest, especially in the manufacturing, in the industry 4.0, but also other kinds of industry that they want to implement their networks, and they want to understand what would be the best way to have their cloud continue in their infrastructure. So yes, we will be open to collaborate.
Okay, thank you very much.
Thank you so much for your questions, Xindong. It's been very interesting to see how these topics are being also interesting for other companies that are working with interoperability challenges. Should we leave a few more minutes to see if there are maybe more questions? If there are, please either type in the chat or raise your hand. If there are not in 1-2 minutes, maybe we should jump into the closing remarks.
Well, doesn't seem to be the case. Then let's jump into the closing remarks. I mean, I've learned a lot, and very obvious, everyone appreciates interoperability, but as I've learned from Andreas, there are 50 shades of federation. So I think, and that was also presented by some of the projects, validation programs and pilots are important, of course, and also initiatives like FACIS. And also what Emma said, adoption and community engagement is key. So here, of course, we have the trade-off between quickly inventing and implementing standards, API standards, which I think George said is the adoption logic, and on the other hand, bringing along a number of implementers, users, and other stakeholders. As the main purpose of the CISERO project is to support the exploitation. We still want to learn a bit better what we can do for the community to discuss and also leverage these aspects. But I think for now, I just want to highlight what's coming next. We have already prepared some events that will happen in the near future, and I just want to give you a quick overview of what's planned in the next weeks and months. So we have, on the one hand, Open Source Community Day at the Eclipse Foundation event in Madrid on the 23rd and 24th of September, where we will give also some insights on open source usage within the Aura initiative. And there is also the upcoming Nexus Forum on the 5th and 6th of November of this year in Brussels, where we will highlight some projects in the context of Cloud Edge and IoT developments. And we also will prepare a webinar on open source within the Aura initiative. This is planned for the 19th of November. Yeah, and with that, I want to thank you all for your valuable contributions, Katja for the moderation, all the speakers for their inputs, and all the participants for giving us also their thoughts on interoperability and how we can go forward with this. And if you have ideas what CISERO, which role CISERO can play in that, we are open to discuss this with you and support you on that. So thanks everyone, and have a good afternoon.